Welcome back to the AI Tools for Developers series, Lesson 6, and this is the one that pays for itself in a single afternoon. Debugging is where AI compounds the most for senior devs, because the real 10x isn't on writing code, it's on finding bugs. The old reflex was read, trace, form hypothesis, test, repeat. The new flow, paste the trace and relevant code, get 5 ranked hypotheses, verify the top one. 30 seconds to first hypothesis. 90 seconds on average from WTF is happening to root cause. So here's what you're walking away with. 4 skills, all sharpened on real bugs. First, the stack trace to root cause flow. Paste, hypotheses, verify, fix. Second, rubber ducking with an AI that actually listens back. Half your bugs surface mid-explanation. Third, log parsing at scale. Drop 200 lines in, let AI find the one anomaly. And fourth, the senior move, knowing when AI is confidently wrong. Race conditions, timing bugs, env-specific weirdness. That's where you stop trusting and start verifying hard. Let's zoom in on that first skill, the 4-stage flow. Stage 1, paste the trace raw. No paraphrasing, no cleanup. AI reads what humans skip. Stage 2, ask for 5 ranked hypotheses, each with a test. That forces structured thinking instead of guesswork. Stage 3, verify the top hypothesis. If it holds, you've found root cause. If not, drop it and move down the list. Stage 4, fix with context. Target the disease, not the symptom. Skip a stage, and you're back to generic answers and slow debugging. Here's that flow on a real crash. Stage 1, paste the raw type error, both stack frames, no edits. Stage 2, prompt the AI with the trace plus the 2 file locations and ask for 5 ranked hypotheses. Look at that ranking. The race condition lands at number 1, and it's correct. Register user awaits db.save, but returns before save resolves. The fix is 1 line. 90 seconds. Disease, not symptom. That's the real 10x, not marketing 10x. Now flip it. Sometimes you don't have a stack trace. You're just stuck. That's where rubber ducking with AI earns its keep. This prompt template does the heavy lifting. Role, context, what you tried, expected versus actual, and crucially, ask me 3 clarifying questions before guessing. Half your bugs surface while you're typing the answers, not in the AI's reply. Stuck means understanding gap, not coding gap. Patch the gap first. Next up, log parsing. Production logs are noise. AI eats noise for breakfast. 3 prompts do most of the work. 1. Paste 200 lines. Ask what's unusual versus the steady state. 2. Build a timeline backwards from the 500 at 1423. What was the sequence? 3. Group and rank, top 5 by frequency, plus the rarest 3, because the rare ones are often the actual bug, while the common ones are just symptoms. Distributed debugging, suddenly accessible. But let's calibrate, because AI isn't magic, and there are 3 bug categories where it'll confidently send you down a rabbit hole. Race conditions. AI reads code, not execution timing, so it misses lock ordering and parallel writes. Environment-specific bugs, works locally, fails CI, AI has no idea about your locale, your container, your file permissions. And state or memory bugs, AI sees current code, not the 4-hour-old runtime state that's actually leaking. For these, you verify hard. Thread sanitizers, env diffs, heap profiles. Senior debugging skills still win. Once the 4-stage flow is muscle memory, layer in these 6 power moves. Occam's prompt forces AI to check the boring causes first. Typos, off by 1, wrong variable. Diff for AI pastes the working case next to the broken one and lets it bisect. Forced trace makes it walk execution line by line, catching state bugs that block reading misses. Then defensive refactor asks for 3 rewrites that prevent the bug class entirely. Treat the disease, not the symptom. Git blame the bug diff's intent across commits for regressions, and save every session. After 20 bugs, your log shows your repeated mistakes and your tooling gaps. Here's the whole lesson on one page. 12 patterns that make up the senior debugger's vocabulary. The left column is your core flow and signal hunting. The middle column is structured thinking, ranked hypotheses, expected versus actual timeline reconstruction. The right column is where you stay sharp. Verify the top guess, skip repeat suggestions, and stay skeptical when AI hits race conditions, env issues, or state bugs. Screenshot this one. It's the whole lesson in 12 boxes. Now the failure modes. 5 ways teams turn AI debug into an hour-long ghost hunt. 1. Pasting the trace without the function around it, so AI guesses your code and guesses wrong. 2. Treating hypothesis number 1 as the answer instead of the first thing to test. 3. Asking for a fix before you understand the cause. That's how the same bug comes back next sprint. 4. Trusting AI on race conditions, timing, and env bugs, where it sounds confident and is often dead wrong. And 5. Letting AI write your postmortem. AI said it was a race condition is not a story. The evidence is the story. So, here's your homework. 3 exercises that turn this from theory into reflex. First, run the strict 4-stage flow on the next real bug at work and time it. By bug 5, you'll be down to 3 to 5 minutes. Second, rubber duck a task you're stuck on right now. Half the time the bug surfaces while you're explaining it. Third, pull 200 lines of prod logs and run all 3 patterns in parallel. Do these, and the 4-stage flow stops being a checklist and starts being muscle memory. That's lesson 6 in the bag. You've got the 4-stage flow, rubber ducking with AI, log parsing patterns, and a clear read on where the model fails you. Daily debugging? Mastered. Next up, we shift tags from daily to advanced. Lesson 7 is AI testing, generating tests that catch real edge cases, mutation testing, property-based prompts, coverage that actually matters. See you there.